What's great about cyclic peptides is they bridge the gap between small molecules and biologics. So, small molecules, fantastic. A majority of our drugs are small molecules. And there's a good reason. Lots of proteins have pockets that fit these things and their sort of classical lock and key mechanism. On the other end of the spectrum, you've got these antibodies, which are doing amazing things for patients, but they're huge and they're not so good at getting into cells. And so you've got a set of compounds that are very specific, but don't get into cells. And you've got a set of compounds that get into cells, but don't bind with the same affinity and aren't useful for the same target class, more importantly.
Right.
So they work against different things and do different things. Cyclic peptides bridge that. And so you have the potential for, small molecule-like properties, such as permeability, which has been challenging, but it's being solved, and oral bioavailability, and the sort of specificity you get with antibodies. So they're the sort of Goldilocks molecules, not too hot, not too cold, just right.
Okay.
And so even within cyclic peptides, you get cyclic peptides at different sizes. So you've got the bigger cyclic peptides, which are made up of 15 plus amino acids all the way up to 25, and there's some people working on even larger sort of mini proteins. And then you've got the smaller sort of, we call them microcycles, which are just 6 amino acids in our case. And they're much closer to the small molecules than they are to the bigger cyclic peptides. So there's a range of them.
Okay.